Theorem 3. The straight line joining the midpoints of two sides of a triangle. D is the midpoint of AC, E is the midpoint of BC, DE is the straight line joining the midpoints of two sides of a triangle. This straight line joining the midpoints of these two sides must be parallel to the third side and half of its length. So let us discover where is the third side. If D is the midpoint of this side and E is the midpoint of this side, so I have two sides, so the remaining side is AB, which will be the third side. What happens? The straight line joining these two midpoints must be parallel to a third side and half of its length. So my givens, I have a triangle named ABC. D is the midpoint of AC, E is the midpoint of BC. My required to prove, I want to prove that the straight line joining these two midpoints is parallel to a third side. So I want to prove that DE is parallel to AB, and I want to prove that DE is half of AB. My construction, draw BF parallel to AD. You can see the signs. That meets the extension of DE at the point F. My proof, I will start with these two triangles. This is triangle number 1 and this is triangle number 2. Okay, from the first triangle is named CED. The second triangle is FEB. I will try to prove that these two triangles are congruent. The first step, I can say that CE, from the first triangle, CE equals EB or BE. Why are they equal? You can see the sign. So because it's given. Number 2, angle x1 equals angle x2. Angle x1 equals angle x2. Why are they equal? Vertically opposite angles. Number 3, angle y1 equals angle y2. Angle y1 equals angle y2. Why are they equal? Alternate angles. Therefore, I can say that these two triangles are congruent. Why? I used this angle and the side between them and this angle. So angle, side, angle. Therefore, the two triangles are congruent. Why are they congruent? Because of angle, side between them, and angle. From the congruency, from this congruency, what do we get? Let us see what we get. Number 1, DE, which is opposite to y1, equals EF, which is opposite to y2. Because y1 and y2, these two angles are equal, so the sides opposite to them are also equal. So DE equals EF. I want to remember this, so here it's inside a rectangle. Number 2, CD equals BF. CD equals BF. You can see CD is opposite to x1, BF is opposite to x2, while x1 and x2, these two angles are equal, the sides opposite to them also are equal. But CD equals AD, Okay, you say CD equals BF, and at the same time CD equals AD. So if we cancel CD with CD, it's clear that BF equals AD. Therefore, BF equals AD. We prove this thing now. BF equals AD, AD equals BF. Okay, if these two sides are equal, and in the construction I said they are parallel, so these two sides are equal, and at the same time BF is parallel to AD from the construction. These two sides are equal, these two sides are parallel, therefore ADFB is a parallelogram. That means DF is parallel to AB. That means DF is parallel to AB. If DF is parallel to AB, DE also is parallel to AB. That means DE is also parallel to AB, and this is the first required to prove, the first one here. Number 2, DF is not just parallel to AB, DF also equals AB. So DF equals AB. DF equals AB. Return back to your rectangle here, this one. DE equals EF. DE equals EF. If DE equals EF, that means DE is half of DF. DE equals EF, that means DE is half of DF. But DF and AB are equal, so instead of saying it's half of DF, I can say it's half of AB, because DF here equals AB. Therefore, I can say instead of DE equals half of DF, I can say half of AB, and this is the second required to prove.